Good morning, everyone. Today I'm going to present the first unit of a digital image processing course titled Digital Image Fundamentals. This unit gives us a foundation to understand how images are captured, processed, and analyzed using computer system. So what is meant by digital image processing means it involves using computers to manipulate images. We commonly see this in everyday applications like editing photos on mobile phones, scanning documents, or viewing medical images. It allows us to improve image quality or extract useful informations. Then why we go for DIP? There are mainly two reasons why we use digital image processing. The first is to enhance images so that they are easier for human to understand, like brightening an image or sharpening a blurry text. The second reason is to prepare images so that computer can interpret and make decisions. For example, identifying tumors in X-rays or recognizing faces in CCTV footage. So what is a digital image? A digital image is just a number of grids. Each number in a grid represents the brightness or intensity at a specific location. Technically, we define it as function f of x comma y, where x and y are spatial coordinates and f is the intensity. If all the values are finite and discrete, we call it a digital image. Basically, it's an image that has been converted into number a computer can understand. So now we are going to see about fundamental steps in DIP. The process of working with digital image is not a single step. There are several stages involved from acquiring the image to finally identifying what's in it. These include acquiring an image, enhancing it, restoring damaged parts, processing colors, compressing for storage, analyzing shapes, segmenting objects, and finally recognizing what the objects are. Initially, we start from image acquisition. Image acquisition is the first and most basic step. Like we capture a digital image using a sensor like camera or scanner. It might also include pre-processing tasks like converting the color format, resizing or removing noise. For example, when you scan a document and save it as an image, you are doing image acquisition. Image enhancement focus on making the image look better visually. We are not changing the actual content, just improving the appearance. This might involve adjusting brightness, increasing contrast, or highlight edges. So think about when you edit your photo to make them clearer. This is a image enhancement in action. Then next is image restoration. Image restoration is about removing defects or noise that occur during image capture. It's more technical than enhancement and uses mathematical models. If an image is blurry or has scratches or interference, restoration tries to recover the original quality, like it's repairing an old photos. Color image processing. This part deals with color image instead of black and white ones. It involves converting between color models like RGB and HSV and analyzing based on color values. It is very useful in medical image diagnosis where images can indicate diseases or in sorting colored objects. Then wavelet processing allows us to analyze images at multiple resolutions, like zooming in and out but keeping useful information. This is especially helpful in compression and when we want to analyze both overall shapes and fine details at once. For example, MRI scan, it can focus on small tissues and the whole organ. Then image compression reduces the size of an image file. This helps in storing more images and transmitting them faster over networks. Two types: lossless compression and lossy compression. Lossless, basically it is perfectly restored, where in lossy compression some quality is sacrificed. So JPEG is a type of lossy compression. Then morphological processing. This step is used to analyze the shape and structure of objects in an image. It is mainly used in binary, like black and white images. It helps in removing unwanted small objects, filling holes, and simplifying image structures. Segmentation. Segmentation is a critical step where the image is divided into meaningful parts. For example, in a medical scan, we may want to separate the brain from a skull or tumor from the tissues. This process is challenging because it needs to be very accurate and very useful in real life application. So once we segment the image, we need to describe the parts. This include measuring the shape, size, perimeter and texture. These descriptions help in further classification or recognition task. For example, if two parts are similar in area but different in shape, and the difference can be important for diagnosis. Then recognition. This is the final step. This is a classification where the system assigns a name or category to the objects based on features. For example, the system may recognize round objects as a tumor or rectangular one as table. So object recognition is widely used in AI, face reduction and robotics. Then to overall summarize it, digital image processing involves multiple steps from capturing an image to interpreting it. Each step plays a unique role and builds upon a previous one. A strong understanding of these fundamentals is essential to design system for medical, industrial and scientific imaging. Thank you all for listening. Thank you so much.